Hi everyone. Now we will present the Realm project. Our group has three members, Doruk Gerçel, Rabia Varol, and I'm Merve Yaman. Here you can see our outline. Now let's start with the problem. Each day, enormous volume of data is generated by different sources. Extracting relevant knowledge from this huge data is a big problem in terms of correlation between different data types, not meeting every requirement of a single knowledge base, and storing data efficiently. Here, the fact that today many systems need to extract relevant knowledge from heterogeneous data for their specific purposes. Our specific purpose is crime and suspect detection. We are working with West Lafayette Police Department. Currently, they prepare incident reports and examine video footage from fixed camera on the city to solve their crimes and track suspects. However, this process is a manual task and takes many hours. We aim to make this process much faster. On our solution, we retrieve data from different modalities. These data sources are video footage, incident reports, and tweets data. Then we construct a common schema for all modalities to represent data. And finally, we build a query engine. Let's talk about our work plan. We have 6 work packages. On the first work package, we make literature review. Then we made database representation. After that, we extract data from video footage. On the fourth work package, we generate tweets for our project. And finally, we develop retrieval methods and make experiments. Now, Doruk will talk about our methods.
Thank you, Merve. As we mentioned, in our project, we deal with 2 different data models, video and text data. The first source that we use is the surveillance cameras for the videos. And also we use tweet records and incident reports for the text data. To deal with the video data, actually we use different models to extract the features from the frames. In this frame, you can see that we extract the features of the suspect as wearing, gender, and race. In order to store and represent these data, actually we created some database tables. And in these database tables, actually we created tables according to the body details of the suspect, the gender, the race of the suspect, and some other incident records. Another data that we deal with is the text records, and one of the sources was the tweet itself. And in order to deal with the tweet records, actually we use Twitter API. While we are representing the tweet records, actually we considered the structure of the Twitter API as well. Therefore, in the tweet records, we just formulated a date, the address of the tweet records, and also the text of the tweet records, like the hashtag as well. Another source was the incident reports. We can consider the incident reports as an unstructured text. And in order to deal with them, we needed to use some models to extract their features. There are 2 models that we use for gender detection and cloth detection. And these models use word2vec. After using these models, we actually merge these in a common annotation. And from them, you can see the data representation of the output, like the gender of the suspect, the race of the suspect, and we try to form a correlation between the video data and the tweet records as well. Now, Rabia will mention the experiments and the results.
Thank you, Doruk. Let me start with the results of video feature extraction. Considering the average performance on all attributes, we choose the image CNN model for the downstream retrieval task. Training is needed for the models except for color sampling, and the image-based baseline and the temporal attention model needed more than 500 minutes to complete the training process. On the other hand, color sampling indeed is more advantageous since it does not need any training. Color sampling can be also a solution for the cold start problem, when there is no training data. However, it should be noted that color sampling works by isolating body regions and evaluating pixel values, so the presence of sunlight or clouds can adversely affect the performance. In the presence of training data, we would recommend using fine-tuned models. For tweet data in real-life scenario, we will be using Twitter API to retrieve real-life tweets about the suspects and incidents. Unfortunately, we don't have relevant tweets about the incidents at hand right now. Therefore, we implemented a script that generates tweet records according to the video features extracted. As future work, we will first compare incident reports with the merged annotation that we create by using two text feature extraction models to see whether these models can correctly extract needed features. Then we will compare relevance between merged annotations and extracted video features and tweet data. Here is our reference list. Thank you for listening. If you have any questions, we will be happy to answer them.